For a given interest rate, present value of 20-year continuous annuity of $1 per year is 1.5 times the present value of 10-year continuous annuity of $1 per year. Calculate accumulated value of 7-year continuous annuity of $1 per year. So it's a continuous annuity. The payment rate is constant, $1 per year. And the interest rate is also constant. We're not given what it is, but it says given interest rate I, which means it's a constant interest rate. So when the interest rate is constant and the payment rate is constant in the continuous annuity, then we know from lesson 93 that it is case 1. And in that case, the present value is 1 minus nu to the 20 over 1 minus nu to the n over delta, basically. So for the 20-year, it would be 1 minus nu to the 20 over delta. And that's the case when the payment is 1 per year, which is the case in this problem. So that's the left side is the present value of 20-year annuity, and that is equal to 1.5 times the present value for 10-year annuity, which would be 1 minus nu to the 10 over delta. We can multiply both sides by delta, and delta goes away. And then we can substitute nu to the 10 as x. So this is x, and this becomes x squared. So 1 minus x squared equals 1.5 times 1 minus x. And so the 1 minus x squared can be factored by the difference of two squares formula into 1 minus x times 1 plus x. And then 1 minus x can be divided out from both sides. So you get 1 plus x equals 1.5. So x equals 0.5. But x was new to the 10. New to the 10 equals 0.5. And nu is 1 plus I to the negative 1. So 1 plus I to the negative 10 equals 0.5. And then you raise both sides to the power negative 1 over 10, and get 1 plus I equals 1.0718. So I is 0.0718. And we needed the accumulated value of a 7-year annuity. So we first choose 93.5, 93.1 to find the present value. Remember our typical procedure for finding accumulated value. First find the present value and then push that present value to where we need to accumulate. So A7 would be the present value of a 7-year annuity. That'd be 1 minus nu to the 7 over delta. So 1 minus 1 plus I to the negative 7. Nu to the 7 means 1 plus I to the negative 7, and I was 0.0718. And delta is equal to ln 1 plus I, so ln 1.0718. This comes out to be 5.546, and then the accumulated value of this 7-year annuity is found by pushing the present value forward through 1 plus I to the 7th. And present value we just found to be 5.546 times 1.0718 to the 7th. This comes out to be 9.01. That was choice D.